last section, we introduced a new function called exponents, and we talked about perfect squares, and where we said, hey, if you multiply a number, we'll call it the base, by itself twice, right? This is just going to be b times b, right? You get a perfect square. This would be just be like b squared, right? And say that was like 3 squared, and you get like 3, 9. It would be 9, right? Because 3 times 3 is 9. Be a 1, 2, 3, 1, 2, 3. Be like 3 rows of 3, 9 rows of 9. Perfect square. Okay. So just like multiplication has division, and addition has subtraction, this one also has its opposite function, and that is called the square root function. The square root function. And we're going to teach you how to use that today. But in order to do that, you need to learn some new symbols and some new terminology. All right, so the first one we're going to learn to use is this symbol right here. It looks kind of like a division sign, but it's not. It is a radical. This is a radical. Radical. Okay? And similar to the base of a square root of an exponent, right? Remember, this was the base and this was the exponent, right? I didn't use e. You can use m. Just don't use e because e is a special number, right? This has a radicand. B is the radicand. Radicand. Okay, that's the radicand. All right, that's a pretty fancy name. And up here would go the index. Index. All right, so this can be a little confusing here. You're not going to have a square root of something unless something has already been squared. Okay, so usually if there's no number here, you assume that it's 2. Okay, if there's an invisible 2 there if there's no number there. Okay, so this, for instance, would be the square root of 4. Okay, so that would be the square root of 4. All right, so similar to yesterday, we said, hey, if there's a 4 right here, this is 4 to the. If it was 4 to the first, this is just 4, and there's an invisible 1, right? This is kind of like if we have a square root. This is the square root of 2, and the index is 2. Okay, you will in the future see things where like this is the radical with an index of 3, and we're going to talk about that in the future. But for now, this is just the cube. This is the square root of 4, and then you can put like a square there or a square here, in which case it would be equivalent, but again, that's future stuff. Okay, so this is, and that would be another exponent. Okay, so let's talk about this a little bit more here. Okay, so like I said, this is the radical, this is the radicand, and this is the index. All right, so when you have you guys remember, a perfect square is the result from a whole number, right? A number without any decimal or fraction next to it being squared. That's a perfect square. All right, so like, remember our table from yesterday? We had 1, 2, 3, 4, 5, 6, 7, 8. And then we had, this was our b value, and we had b to the n, right? And then we had, remember, this was 1, 4, 9, 16, 25, 36, 49, 64. We had a 9. This was an 81. 10 would have been 100. Oops, blue 100. And I'll put like 11 is 121. 121, 12 is 124. These are good just to memorize up to like 12. Up to 12 is good to memorize. And then remember, its negative version is also true, because when you square a negative, it becomes positive, because when you multiply a negative times a negative, you get a positive as a result. Anyway, so if you see a square root of a perfect square, PS equals perfect square, perfect, S-Q-U-A-R-E, it ends up being that number that was squared together. It's root. It becomes its root, right? These are the roots of that perfect square. Okay, so this would be 2, right? If this was the square root of 9, it would be 3. If this was the square root of 36, it would be 6. If this was the square root of 64, it would be 8, right? So, how about the square root? Well, technically, if you want to be more technical, this is plus or minus each one of these. Plus or minus each one of these, because you can square each one of these, right? The negative or the positive variation of these, and get that inside, get that as a radicand. All right, so that is that. Let's see if there's anything else. How about this? All right, so another way to kind of break these down, if you didn't memorize all this stuff, or say you had, something higher than what you memorized, say, let me see something that's a little higher. Let's do like one. Say we had like, I don't know, let's do, how about that one? How about 256? Square root of 256, and you're like, oh man, I don't know what that is. Well, you can start breaking this down into factors, right? Well, I know that's divisible by 2, right? Because it's an even number. I can do let's see. Let's do 256 divided by 2. Well, 25 divided by 2 is going to be 12.5. Let's do it. Okay. 25 divided by 2 is going to be 12. And I can do 2 12s, and that's going to be 24 with 1 left over, a 16, that's going to be 128. So I have a 2 and a 128 inside of there. I keep that radical in there, bring down the 2, and 128 I can break down into 6 and 4. So 64 and 2. Hey, cool. A 2 times a 2 is a 4. That's a 4. Hey, and so I can bring out this 4. That's a 2. Okay, and 64 is an 8. Okay, well 2 times 8 equals 16. So the square root of 256 must have been 16, right? And if I go over here and I look at that and I do this, hey, look, lo and behold, it was indeed 16. So that the factors can get pulled out, and when you pull out the factors and you take the square root of the factors of that, and if they get pulled out, you multiply them together and they become the square root as well. The same of that is true as well. And if they don't get pulled out, they just get left inside, and that's in the future. That's algebra. But anyway, let's move on past that. I hope this all makes sense.